So the project I'm part of deals with fabric.
We came up with this idea that we could knit our way into all kinds of structures like bicycles, hoods for cars, parts of airplanes, etc.
The textile aspect of the composite that's quite unique, and that's kind of one of the avenues that we're pursuing. How does that then play out into making a composite? The knit provides a lot more flexibility, which is very different from a weave, because you can have the one area that's super rigid that needs to be rigid, and then you can have another area which is much more flexible because it needs to be flexible.
One important property of composites is toughness. If you've seen these Indy 500 races, Formula 1 races, you've seen cars crashing at really high speeds, but then you see the driver just walking away. The reason is that when these things break, they break rather gracefully. They absorb a lot of energies. It's sort of diffusely cracking. It beats most metals very easily.
All right, time to start it up.
So despite the fact that we look like a strange kind of team, and this is not the typical things that get funded, MCubed funding allows us to demonstrate that this actually has legs. MCubed is an initiative at the University of Michigan that tries to help faculty at the university to identify collaborators to nurture research projects that span multiple departments.
MCubed kind of allowed us to make the hypothesis and give us the time to research its usefulness and its application. I mean, honestly, we've certainly learned a lot about what has been done, what hasn't been done, what direction we should head in.
There are already like carbon fiber reinforced composites and other braided textile composites that are used for structural forms, but they tend to be labor intensive. With knitted and certain types of braids and woven materials, you can produce the backbone very quickly. If you can also infuse it very quickly, which can be done, you can produce very intricate structural forms rigidly for actual load-bearing purposes, and then you can do it rather cost-effectively.
There's no waste, there's no cutting, there's no sewing. The thing, which is actually a fully three-dimensional structure, can be produced directly off the machine.
You're getting several desirable effects using one material: lightweight, producibility, and the fact that they are highly damage tolerant and very crash worthy. I think it's a matter of time before people will realize that this is the material of choice in the near future.